Today we are going to discuss about concept of rational numbers on the number line. So rational number form will be given in that diagrams what is mentioned over here and followed by represent rational numbers on the number line. We know that natural number and whole numbers in the form of number line and followed by together natural number and whole number. For negative numbers will be integers also will be in the format. But how to represent rational number on the number line? A number line look like something like this. So the positive integers toward the right of the zero, the negative integers represent the left of the zero, either positive or negative. So right is the positive, left is the negative. It can easily plot some integers like that, but how to plot the number line? In a number line we have to plot the number of like 3 by 4. So before we have to understand, so how do we have to plot this? So we need to know some important point, either positive side or negative side. Except 0, all the numbers have the corresponding integers. 1 is the correspondent to -1, 2 is correspondent to -2, similarly 3 is correspondent to -3, 4 is correspondent to -4. Similarly negative numbers also have the corresponding of positive numbers. So it says that how do we plot the number line of -3 by 4 in the given things. So it will be very simple. Now we can move the representative of the number line. So -3 by 4 will be lies between 0 to -1, 3 by 4 will be 0 to 1. The rational number will be given in the platform like this. So 0 to 1 number dividing in by, so two rational numbers between infinite number of rational numbers are there. So the rational number will be classified into two types. The first one will be numerator less than denominator. The second one will be numerator will be greater than the denominator. Okay, we understand very clearly about how to represent a numerator will be less than denominator, numerator will be greater than. So the -9 by 5 how to represent on the number line. So numerical only we have to consider. For example, minus by 5 you have to consider 9 by 5 only. We are not consider the minus. So for example, rational number also represent in the form of number line. That example is the first step. In a rational number, the number below the bar, that is the denominator, tells the number of equal parts into which the first unit has been divided. The numeral above the bar, that is called numerator, that is tells how many of these parts are considered. So in this particular example we need to divide the first unit into 9 parts because denominator is 9, and we need to move the part of fourth one because the numerator is a 4. So now how to draw a number line? So draw a straight line, divide first unit into equal parts equal to the denominator of the rational numbers, and then mark the equal parts right to the line reach the desired number. Here the diagram is very clearly given about the statement of 4 by 9 on the number line. So we are dividing in the number line. Okay, fine. Next, so -3 by 4 also will be represented in the format. We have to take 3 by 4. We are not consider the minus as I mentioned before. This numerator is less than denominator example. Then we can come for the another one, -9 by 5. We have to represent only 9 by 5. You have to consider this the numerator of 9 only. In this case, this numerator will be greater than denominator. We are not consider the sign. We are consider only the numerical values. Okay, we have to go for the first example, how to represent the numerator less than denominator number. So one big small example we have to consider 1 by 2 and -1 by 2. The numerator 1 is less than denominator 2, but the numerator is less than denominator. Then a positive rational number between 0 and 1. So we have to draw the number line like this. So the number is lies between 0 and 1. Now we have to draw the number into 0 and 1 to equal parts. How many equal parts we have to divide? So denominator tells how many number of parts we have to divide it. The denominator is 2, so we have to divide it into 2 equal parts. So now this region will be divided into 2 equal parts. But what the numerator will be tell us? What's the number of parts will starting from the 0. The numerator is 1, so we have to move one part from the 1. So the number of part will be 1 by 2. So similarly we have to represent the number of minus 1 by 2, divide the number of 0 to 1 into 2 parts. So we have to represent the number of minus 1 by 2. So this is the way how to represent over the number line. So minus 1 by 2 is the corresponding integer of 1 by 2, as we know that previous discussions. Okay. Now let us take the second example over here, which is numerator is less than denominator. We have to plot the number of 3 by 4 and minus 3 by 4. Okay, let us draw the first 3 by 4 first. The numerator is less than denominator, so it is lies between 0 and 1. So we have to draw the number line like this. So now denominator is 4, so it tells the number of 4. So we have to divide the denominator into 4 equal parts of 0 to 1. So now divide the numbers 1, 2, 3 and 4. Now what the numerator will tell us about? So as we know that numerator will tell how many numbers we have to shift over. So here the numerator will be 3, so we have to move the numbers to 0 to 1, 2, 3. So which is nothing but the number of point is representing as a 3 by 4 over there. Okay, now we have to represent the minus 3 by 4 here. So if you take the left side, 0 to minus 1, that will be dividing into 3 equal parts, 4 equal parts, because denominator is 4. So we are going to divide it, and the numerator represents the 3. So we have to 0 to minus 3, we have to represent of minus 3 by 4. Now let me ask you a question. You have to plot a number minus 3 by 4, 3 by 4. But what about the between the numbers? These points. Yeah, we have to get the answers over here. 0 to 1, it's called as a 1 by 4. 0 to 2 is called as a 2 by 4. Similarly, we can take the negative side also. Negative side also, minus 2 by 4 and minus 1 by 4 too. You don't need to mention all the points over here, because they ask the question 3 by 4 and minus 3 by 4. Just represent only the given numbers. No need to represent all the number of this. Okay, now here the represents, we are going to use the next example of 7 by 4 and minus 7 by 4, where the denominator is greater than the numerator. We have to come for the next problem, 7 by 4 and minus 7 by 4. 7 by 4. So in such kind of problem, numerator is greater than denominator, so we have to convert to mixed fractions. So how to come to the mixed fraction? I will give a small example for you how to write it over. So 4 divided by 7 is equal to 1 is the quotient, 3 is the remainder. So we have to write in the format of quotient remainder by divisor, where 1 3 by 4. 1 is called the whole number and 3 by 4 is called the proper fractions. Each of the numbers will be represent how to write the number of 7 by 4. The whole number tells us the position of the number. 1 is the rational number, so it will start from the 1, and the next whole number will be represented by the 3 by 4. So 3 by 4 means it's represented close by the next one of 2. So this number is lies between 1 and 2. So now we have to draw the number line according to that, where 0 to 2, which numbers is representing of 0 to 2. So now we have to look out the denominators 4. So number of equal parts we have to divide it into 4 equal parts. So better you can divide after 1, because 1 is the whole number. We have to divide after 1 into 4 equal parts. So now the numerator of the parts is away from 1 will be tells that how many parts we have to move after that, after 1. So now we have to one after we have to move on 3 parts, because the numerator is 3. We have to shift ourselves to 3 parts, where 7 by 4. So the number similarly this is called the positive number. Similarly we can represent the minus negative number of minus 7 by 4 also, where numerator is greater than denominator. We have to convert into the mixed fraction in the format of minus 1 by 3 by 4. The same process what we done in the right hand side, we are going to do the left hand side. The number is lies between minus 1 to minus 2. So the equal parts we are dividing into 4 parts, and the numerator will tells the number of parts away from 1 is minus 1. So now it will be divided into 1, 2, 3, 4. So we have to represent the number of minus 7 by 4 over there. So this is the way how to represent the numerator and greater than the denominator numbers. So here I am giving a short note over there how to plot the rational numbers. So if numerator is less than denominator between 0 and 1 or 0 and minus 1, use denominator to split into the equal parts. Use numerator to count the number of parts. You will get the solution over. If you go for the numerator is greater than denominator, convert to mixed fraction is the first step between the whole number and the next whole number, the first number and second number. We have to consider over. Use denominator as a fraction of split into the equal parts, and use numerator to fractions to count the number of parts. This is very simple and shortest note where you have to use convert the numbers into the format of rational number. That's okay. The next thing we are going to represent on the exercise problem. Represent these numbers on the number line 7 by 4. 7 by 4 is numerator is greater than denominator. So we convert it to the mixed fraction first. 1, 3 by 4 where we are getting the answers. Now we are plotting the numbers 0, 2, 1 and 2. So this one number is less between 1 and 2. That's why we are splitting into 4 by 5. So it's one of the simplest way. So we have to represent 0 by 4, 1 by 4, 2 by 4, 3 by 4, 4 by 4, 5 by 4, 6 by 4, 7 by 4, 8 by 4, 9 by 4, 10 by 4, and we have represent on the point of P. It's very simple solutions to get it over. Come to the first question, second option, minus 5 by 5. So this is minus, so it's numerator less than denominator. So we have to divide into 6 equal parts and divide to 0 after. We have to move to the 5 parts and we have to mark the value of m. So here m is represent the solutions. Okay, now we have come for the third question. Second question, represent minus 2 by 11, minus 5 by 11, minus 9 by 11 on number. Here I am representing b is equal to minus 2 by 11, c is equal to minus 5 by 11, d is equal to minus 9 by 11. All have equal denominator, so the work is very simple for us. Take the straight line of number line and we have to represent the numbers 0 to 1 and we have to get it because all the numbers are numerator is less than denominator. So our work is very simple to represent these kind of numbers into the problems. Okay, fine. So now shall we go for the next one? Any doubt in this question, students? Okay. Now we are going to next step in rational number between two rational number, because every two rational number between infinite number of rational numbers will be there, because 0 to 1 we have 0.1, 0.2, 0.1 and 0.2 between we have 0.01, 0.001, 0.0001, which just tell us 1 by 10, 1 by 100, 1 by 1000. It will go infinite number of that between two rational numbers. The first example is find three rational number between 1 and 2. That is two method is there. I am telling the both the method also. The first method is average method. We know the average of two numbers, rational numbers, lies between them, and that is also rational number. The first step, find the average. 1 plus 2 divided by 2. So 1 plus 2 will be 3. So 3 by 2 is also a rational number. That's what they given. The 3 by 2 is lies between 1 and 2. The step 2 is now find 1 and 3 by 2 between the average of the numbers. If you find 1 and 3 by 2 between the average, also will become as a 5 by 4. So 5 by 4 also is lies between 1 and 2. So that is also a rational number. And similarly we have to find out 3 by 2 and 2 will also lies between 1 and 2, where the answer is 7 by 4. So 7 by 4 also a rational number. So 3 by 2 and 5 by 4 and 7 by 4 also rational number. In the general form a and b, the two rational number is a plus b divided by 2 is a rational number between a and b are such that a is less than a plus b divided by 2 less than b. So this is also one of the method. You find the average of the two numbers and you can find the midpoint. Like that you have to find the midpoint of each numbers between two numbers. You will easily get the solution of that. So definitely midpoint means the number is lies between the both the numbers, right? So we have to go for the, this is one of the difficult one, and we can go for the another method. That is the very simplest one, nothing but find the LCM of the concepts. So simply we have to convert the denominator into the same value. That is nothing but how to convert it, taking the LCM and convert into the denominators or same denominator, like a fraction of addition subtraction. We used to do that. So 1 by 3 we have to convert into 2 by 6. 7 by 2 we have to convert into 21 by 6. Now both the denominators are same. Now between 2 by 6 and 21 by 6 we have lot of number like 3 by 6, 4 by 6, 5 by 6 till infinite. This is the easiest way to find the rational number. So better we have to follow all of you in the second method, how to represent denominator. Now we can come for the example. Find the 10 rational number between minus 2 by 5 and 1 by 2. So the denominators are not same. So we have to find the LCM. LCM of 5 and 2 is 10. So if you want to make the 10, the first term will be multiple with 2 by 2. The second term is multiple with 5 by 5. So first term is multiple 2 by 2. Minus 2 into 2 will be minus 4. 5 into 2 will be 10. And the second term will be 1 into 5 is equal to 5. 2 into 5 is equal to 10. Product of numerator by product of denominator. Now again you can check it over there. Minus 4 by 5 and 5 by 10. 5 by 10. Between that only uniform number. For example 3, minus 2, minus 1, 0, 1, 2, 3, 4 only will be there. So we have to need 10 numbers. So we have to multiply with the 2 by 2. It's not necessary you have to multiply 2 by 2. Suppose if you want you can multiply 10 by 10 also, because you need 10 numbers only. So now here we are multiplying with 2 by 2. So minus 4 by 10 into 2 by 2 is equal to minus 8 by 20. 5 by 10 into 2 by 2 is equal to 10 by 20. So the 10 rational number between 1 by 2 and minus 2 by 5 are 7 by 5, minus 6 by 5, minus 5 by 5, minus 4 by 5, minus 3 by 20, minus 2 by 20, minus 1 by 20, 0, 1 by 20, and go on. Okay, now find the next question. Find the rational number between 2 by 3 and 4 by 5. Here too the denominators are not same. So we have to find the LCM of 3 and 5. LCM of 3 and 5 is equal to 15, where we can get the resultant of the first term we have to multiply with the 5 by 5, second term we have to multiply with 3 by 3, where we have to get the denominator as equal. So 2 by 3 into 5 by 5 is equal to 10 by 15. 4 by 5 into 3 by 3 is equal to 12 by 15, where the two denominator 10 by 15 and 12 by 15 are same, but in between we have only one rational number which is nothing but 11 by 12, 11 by 15. But we need 5 numbers, so we have to multiply with the 4 by 4, or you can multiply with the 10 by 10 as your convenient, but I am doing here over 4 by 4. 10 by 15 into 4 by 4 is equal to 40 by 60. 12 by 15 into 4 by 5 is 4 is equal to 48 by 60. The 5 rational number between we can get the solution over. Okay, now the next question. The 5 rational number between minus 3 by 2 and 5 by 3. Now here too the denominators are not same. So LCM of 2 and 3 is equal to 6. So we have to convert the denominator. First one will be multiplied by 3 by 3. Second term will multiply with the 2 by 2. We are getting the resultant of minus 9 by 6. And we are getting the resultant of 10 by 16. So where we are getting the resultant of 8 by 6, minus 7 by 6, 0 and 1 by 6 and 2 by 6 and so on. So now next number. Find the 10 rational numbers between 3 by 5 and 3 by 4. So the LCM of 5 by 4 and 5 and 4 will be 20. The first term is multiple with the 5 by 5. The second term is multiple with 4 by 4. Where you are multiplying with the 5 by 5 and 4 by 4, we are getting the answer of 15 by 20 and 12 by 20. So the again resultant is coming as 120 by 160 and 96 by 160. So the 5 rational number, how to find out over nothing but, so 120 to 160, 96. 96 after 97 by 160, 98 by 160, 99 by 160, till you can get a number of 119 by 160. So between you can take any 10 number as your wish. This is the easiest way to find the LCM. Make it the denominator as likable, and you have to multiple with any number of, better you can multiple 10 by 10. That's very easiest one, and we are getting the solution of the given problem. Okay, here I left out few problems like as sixth problem and so on. So that problem I request you people to do it by your own and try to get a solutions. Okay kids, any doubt in this problem? Suppose you have a doubt in this problem, better I suggest you people to go for the average method. Now I just do the small recall, the rational number. So what is the rational number? Any number that can be expressed in the form of p by q, where p and q are integers and q is not equal to 0, is known as the rational number. The collection of group of rational numbers is denoted by q. I hope you all know that. Just recall the rational number of properties, a short note. The chapter is over. Now the properties of rational number is, we have the properties of closure, associative and commutative. So closure property, rational numbers closed under addition, subtraction and multiplication. Division it will not satisfy. If you have a doubt, just go for the previous video and check out over. And next, commutative property, rational numbers are commutative under addition and multiplication. This is also not satisfied for the divisions. And we have a small note also, so which is nothing but, Rational number, integers and whole numbers are commutative under addition and multiplication. Rational numbers and integers and whole numbers are not commutative under subtraction and division. That's what the last video we discussed. I explained you people. And associative properties also will be satisfied only addition and multiplication, not satisfied for subtraction and division. The role of 0 and 1 also will be explained. 0 is the additive inverse for the real number, rational numbers, and 1 is the multiplicative identity for the rational numbers. And when you come to the part of inverse, inverse is nothing but exchanging the numerator and denominator, like reciprocal. If the product of two rational number is 1, then they are called the multiplicative inverse of each other. Okay, fine. Okay, students, this is up to this. The chapter is over. The first chapter is over. I request you people to work out the exercise problem and followed by example problem. The worksheet will be posted at the time of 12:15. Please do the worksheet and try to submit as soon as possible. And just whenever you have the free time, please I request you people to go through the mind spark. And thank you so much. Thank you for your time. If you have any doubt, please recall the videos, check the videos and read it again. Thank you so much.